Evaluating functions. So let's start with something that's linear. So this is a linear function. F of x equals 5x minus 9. We know it's linear because the exponent of x is 1. Okay, and remember this guy right here is like a y, like y equals 5x minus 9. Evaluate. That just means we are going to replace the x right here with whatever is in here. So f of negative 1 means every time we see an x up here, there's an x in f of x and then an x that's multiplied by 5, we're going to write negative 1 in its place. So f of negative 1 is 5 times negative 1 minus 9. Okay, because we have taken every x and replaced it. We've replaced this x with a negative 1, negative 1. So that means we're going to replace this x as well with a negative 1. So 5 times negative 1 minus 9 is negative 5 minus 9. We get negative 14. Let's do it again. So now we see instead of x, we had f of x. We've replaced this x right here with a negative 4, which means we have to replace this x right here with a negative 4. This is 5 times negative 4 minus 9. 5 times negative 4 is negative 20 minus 9. This is negative 29. Let's keep going. F of 5. So remember we had f of x equals 5x minus 9. We've replaced this x with a 5. So now we replace this x with the 5. So another way I like to say is this function tells us that our input is x. So remember we have points that look like x comma y. This is the input comma output, x comma y. F has an input of x. What do we do to that input? We take that input and multiply by 5, then we subtract 9. This says f of 5, which means I've replaced my x with the 5. My new input is 5. So 5 times 5 minus 9. 25 minus 9 is 16. So keep in mind, each of these could also be written as a point. We know that we have points x comma y. So if we say f of negative 1 equals negative 14, that means there is the point negative 1, negative 14 on the graph. The same over here. So the point negative 4, negative 29 is also on that graph, on that line. So is the point 516. And we can keep saying this. So just keep in mind, that's all we're doing when we're evaluating. We replaced our input x with, in this case, these three cases, numbers, and the output is another number. Now we're going to see in examples in a few minutes where we don't always have to have an input that's a number. But let's continue. So f of 11 says we've replaced that x with 11. The new input is 11. So this is 5 times the new input minus 9. So 5 times 11 minus 9, which is 55 minus 9, and we get 46. So again, we also have the point 1146 is on that line. Okay, let's try some more. So f of negative 2, we have one more that's a number. We've replaced this x right here with a negative 2. So we have 5 times the new x, the new input. So 5 times negative 2 minus 9. What's that? Negative 10 minus 9, negative 19. So again, the point negative 2, negative 19 is on the graph of the line y equal 5x minus 9. Okay, what about this one? F of k. So again, we have replaced this input x right here with the k. So this is 5 times k minus 9. Okay, so this one isn't as obvious that it's a point, but you can change the k values maybe and get different points. But my input is k, the output is now 5k minus 9. Let's keep going. So if we have f of m plus 1, remember my function f of x was 5x minus 9. We are replacing this x with m plus 1. That means you replace every x with m plus 1. Be very careful here. This is 5 times m plus 1. It's multiplied by the whole thing. If you had written this as 5m plus 1, that is not correct, because that just says 5 is multiplied by m. We want the 5 to be multiplied by both pieces. You must use parentheses. Okay, and then if we want to clean it up, we can distribute. So 5m plus 5, because we are using the distributive property, 5 times m, and then 5 times the positive 1. So 5m plus 5 minus 9, we get 5m minus 4. Okay, let's try another one. F of x cubed. So now we have replaced this x right here with x cubed, which means we must replace this x with the new input that we've chosen, which is x cubed. And this one really can't be simplified very much. This is 5x cubed minus 9. Let's try another one. So what if we have another function, f of x equals 15 minus 3x? This is linear because the exponent of the x term is 1. So if f of x equals 15 minus 3x, we're going to evaluate. So we want to say, well, we've replaced this x right here with 3x minus 1. So we're going to replace this x with 3x minus 1. Okay, and if this is hard for you, you can come do some scratch on the side. So maybe it bothers you that you're not plugging in just a number anymore. So let's try for you. If we do like f of 1, that's 15 minus 3 times 1, because we're replacing that x with a 1. Let's not simplify for this at this point. F of 4, that's going to be 15 minus 3 times 4. Do you see what we're doing? We are just replacing every x, in this case, with the 4. F of 19.1, that's going to be 15 minus 3 times 19.1. Here we're just trying to make sure we understand the pattern. Okay, so f of 123, that's going to be 15 minus 3 times 123. Okay, f of 87. Again, I'm pulling numbers out of the air, just hoping you can recognize the pattern. This is 15 minus 3 times 87. And I'm going to stop highlighting. Let's do some more. F of 126. That's going to be 15 minus 3 times 126. F of 19. That's 15 minus 3 times 19. F of 1.4 will be 15 minus 3 times 1.4. So what's f of 3x minus 1? Well, that's going to be 15 minus 3 times 3x minus 1. I tricked you. So if you struggle with this, if this is hard for you, just plug in a whole bunch of numbers until you start to get the pattern. What you're going to notice is you're kind of lulling yourself into complacency. There, at some point, probably maybe right here, there's a time when your brain sort of shuts off and you turn on autopilot. You're not actively thinking about it. It has become like rote. It's become a routine. So you just sort of plug in. You're like, okay, whatever's in here, I plug in here. And your mind has established the pattern. So you see that you can trick yourself and you can do this very easily. But let's confirm the way we've been doing it. This is f of x is 15 minus 3 times x. Whatever my input is here, I do 15 minus 3 times the input. So 15 minus 3 times the new input. Do you see that? So this is 15 minus 9x plus 3. We simplify this to get, we're going to look at 15 plus 3. That's 18 minus 9x. Keep going. So I've changed the input to 5 over x. So this is 15 minus 3 times 5 over x. That makes sense? And we can clean this up a little bit. We can write this as 3 over 1. And we're looking at fractions. We can multiply the numerator times the numerator, like this, and the denominator times the denominator. Okay, because if you have fractions, a over b times c over d, we get ac over bd. So you end up with 15 minus 15 over x. And if you want to build a common denominator, you can, but you don't have to in this case. So let's keep going. F of the cube root of x. So let me remind you what f of x was. F of x was 15 minus 3x. We have replaced this x with the cube root of x. So we're going to replace this x with the cube root of x. Oh, look, f of x plus h. So we're going to replace that x with x plus h. So this is 15 minus 3 times x plus h. That makes sense? 15 minus 3 times the new input. Let's clean this up. We can distribute that negative 3 to both pieces here. So we end up with 15 minus 3x minus 3h. Okay, let's continue. Oh, look here. This part, f of x plus h, is the same thing we just found. Okay, and there's a new piece. Now it says minus f of x. So we're just going to recopy the previous part, 15 minus 3x minus 3h. Then we're going to subtract off the original. So the original was f of x equals 15 minus 3x. So I'm going to write this right here. I just found f of x plus h in the previous step. Now I'm going to subtract the original function. Now, some of you may be tempted to write it like that, and that's wrong, because what this says is you're subtracting 15 and only 15. You have to subtract the entire function f of x, which means you have to subtract all of it, which means you must use parentheses. So then we can distribute that negative sign. When you do that, you get 15 minus 3x minus 3h minus 15 plus 3x. Does that make sense? Now, can we combine any like terms? Let's check. Oh, look, we have 15 and a negative 15. We can cancel those. We have a negative 3x and a positive 3x. We can cancel those. So we end up with what? Just negative 3h? So if you're doing something like this is really kind of a fun algebra problem. This is a piece of something called the difference quotient. I'll show you that in a second. But at this step, every term without an h will cancel, or you screwed it up. So this part right here, this is something really fun. You're going to use it a lot if you continue your math. This is called the difference quotient. So the difference quotient, if you notice, we've already been building to that. We did f of x plus h. Then we did f of x plus h minus f of x. If you look, the numerator here is this. Okay, let me highlight this in purple. This, which we found out was negative 3h, is your numerator. Okay, so I'm going to go ahead and write the other part. It was 15 minus 3x minus 3h minus 15 minus 3x. All of that is now divided by h. Okay, just to kind of label what we did. This part right here was the f of x plus h part from a previous step. We have subtracted off the f of x. So we see that in the previous step we cleaned this up. We got 15 minus 3x minus 3h. We distributed that negative 1. So minus 15 plus 3x all over h. And then we saw some stuff canceled, right? That's where the negative 15, the positive 15, the negative 3x, the positive 3x, all that canceled. I'm just redoing the steps from above. So we end up with negative 3h over h. So I could have just jumped to right here, because that's the answer we got when we did this the first time, this piece. But I wanted to remind you where this came from. Oh, look, now we can clean up some more, right? There's an h in the numerator and h in the denominator. This simplifies to negative 3. Okay, so this is the difference quotient. And again, when you do this, when you do the f of x plus h minus f of x step, every single term that does not have an h in it will cancel, or you screwed up. Okay, because you were subtracting off the function. Okay, when you simplify, you expand everything out, there's going to be some redundancies.